Hello, I am Luis Rafael E. Quinones, and this video is to explain the four concepts of OOP, which are encapsulation, inheritance, polymorphism, and abstraction. I will discuss its importance in OOP and how they can be achieved. Number 1. Encapsulation. So what is encapsulation? Encapsulation is the bundling of data and methods that operate on the data into a single unit or class. It hides the internal state of an object and only exposes the necessary functionalities to interact with it. Encapsulation ensures data integrity and prevents direct access to sensitive data, promoting modularity and ease of maintenance in software development. Here's an example illustrating encapsulation using a simple analogy or scenario. Imagine a safe deposit box at a bank. The box itself represents an object and the contents inside represents the data. The bank provides a key or combination lock to access the contents, acting as methods to interact with the object. The customer can only access the contents through the provided access mechanism. While the inner workings of the safe deposit box remain hidden, this encapsulation ensures the security and integrity of the contents as they cannot be directly manipulated without proper authorization. This is how encapsulation is achieved in Python through classes and access modifiers. In Python, encapsulation is achieved using classes and access modifiers like public, private, and protected. Here's a code snippet. In this example, brand is a protected attribute accessible within the class and its subclasses, while model is a private attribute accessible only within the class. Outside the class, we can access the protected attribute using a single underscore prefix, but the private attribute is not directly accessible. Number 2 is inheritance. What is inheritance? Inheritance is a fundamental concept in object-oriented programming where a new class or a child class is created by inheriting attributes and methods from an existing class or the parent class. It promotes code reusability by allowing the child class to inherit the functionalities of the parent class, reducing redundancy and facilitating modular and scalable code development. Here's an example illustrating encapsulation using a simple analogy or scenario. In this example, the animal class is the parent class with a name attribute and a placeholder speak method. The dog class is a child class of animal inheriting its attributes and methods. The speak method is overridden in the dog class to return woof. This is how inheritance is implemented in Python and how child classes inherit properties and methods from the parent class. In Python, inheritance is implemented by specifying the parent class in the definition of the child class. The child classes automatically inherit all attributes and methods of the parent class. Here's a code snippet. In this example, the child class inherits from the parent class, so instances of child have access to both parent property and parent method in addition to their own properties and methods. The third concept of OOP is polymorphism. This is how we define polymorphism in OOP. Polymorphism is the ability of objects to take on multiple forms or behavior depending on the context in which they are used. In OOP, polymorphism allows objects of different classes to be treated as objects of a common class, superclasses. This promotes flexibility, extensibility, and code reuse by enabling code to work with objects of different types through a common interface. Here's an example illustrating polymorphism through method overriding or method overloading. In this example, both rectangle and circle are subclasses of shape and override the area method to calculate the area specific to their shape. Despite being different shapes, both rectangle and circle can be treated as shape objects, allowing for polymorphic behavior. This is how polymorphism is achieved in Python and how it allows for flexibility in code design. In Python, polymorphism is achieved through method overriding, where child classes provide their own implementation of methods inherited from the parent classes. This allows objects of the different classes to be treated uniformly, providing flexibility in the code design. Here's a code snippet. In this example, the total area function takes a list of shapes as input. Despite the shapes being of different types, polymorphism allows the function to calculate the total area uniformly by calling the area method on each shape object. This flexibility in code design enables the easy addition of new shape classes without modifying existing code. The fourth concept of OOP is abstraction. So what is abstraction? Abstraction is a process of hiding the complex implementation details and showing only the essential features of an object. It allows developers to focus on what an object does rather than how it achieves it. In OOP, abstraction is achieved through abstract classes and interfaces which define a blueprint for other classes to follow. Abstraction simplifies code complexity, enhances code readability, and promotes code reusability. Here's an example illustrating abstraction through method overriding or method overloading. In this example, animals is an abstract class with a method makeSound that is meant to be overridden by its subclasses. The subclasses dog and cat provide their own implementation of the makeSound method, demonstrating abstraction by hiding the implementation details of how each animal makes its sound. This is how abstraction is achieved in Python and how it allows for flexibility in code design. In Python, abstraction is achieved through abstract classes and interfaces. Abstract classes cannot be instantiated directly and may contain one or more abstract methods that must be implemented by their subclasses. Interfaces define a contract for classes to implement, specifying the methods they must provide without any implementation details. Here's a code snippet. In this example, shape is an abstract class with an abstract method area. The rectangle class implements the area method, providing its own implementation. Abstract allows the flexibility in code design by defining a common interface shape that other classes can adhere to while provide different implementations like rectangle, circle, and other shapes based on their specific requirements.